before we start everything, we're going to go into our demo reel that we have at the Academy Software Foundation, representing work of studios that are using our open source projects. So let's go with that. So in the next half hour, we're going to give you an overview of the Academy Software Foundation at two levels, the many things we do with our community, and talk about some of our projects. And I'm glad to be co-presenting with Larry Gritz, who is at Sony Picture Imageworks, and also our Technical Advisory Council Chair at the Academy Software Foundation. We are in the motion picture industry, which is a great place to be if you love movies and if you love making cool images and computer graphics. I'll retrace here a little bit of how open source played an increasingly large role in the motion picture industry in our small community. So our agenda is going to be this. We're going to talk about open source in motion picture, what's the Academy Software Foundation, what we do, and our open source projects, some of them, and how you can participate if you're interested in the movies. So open source in motion pictures. We have to start with this news that you heard in Jim Zemlin's keynote on Monday, the movie Flow. So the movie Flow, we cannot understate how this is important in our motion picture industry, what was achieved by that team. So Flow, one independent film project directed by Jin Zilbalodis, made history when it became the first Academy Award winner for animated feature film to be made entirely with the open source software with Blender, open source 3D creation suite. No need to introduce Blender, you all know about it. Now what is lesser known is that Blender used a number of our Academy Software Foundation projects when it comes to making professional movies. Blender is used to do many things, but when the team in this case used OpenColor.io, OpenEXR, OpenVDB, MaterialX, OpenImage.io, Open Shading Language, and OpenTimeline.io. I want to point out that OpenImage.io and Open Shading Language are projects that were started by Larry here himself and that are now part of the foundation. So with Larry, you have really someone who is intimately involved with the development of open source projects in our industry. I want to say a few more things about Flow. Flow, the budget was less than $4 million, and they made the movie by a core group of 5 people and an extended group of 45 contractor that they hired on a need basis. And they made that movie. It made $36 million at the box office. Not a lot of money if you compare it to the big blockbusters, animation movies from Pixar DreamWorks that make hundreds and hundreds of millions, but enough given the budget to be profitable. And so this is a groundbreaking moment where independent cinema that exists, since the beginning of cinema, and on the live action side, you have hundreds and hundreds of independent movies that come every year. But now is the first time with Flow that you can have an animation movie done with computer graphics at the level of budget that is similar to what you have for independent movies on the live action side. In the US, there is this bar in budget, which is about $5 million, where below that number, you benefit from a lot of subsidies and you can have help for your independent projects. That's really where the independent movie is. And Blender is the first to prove in a big way that you can do an animation movie in those budgets with a small team using open source software. So it's a great achievement. And we're glad for them to be doing this. Now, if we're stepping back and looking at open source in motion picture, or stepping up and getting some perspective, so we have our projects, and we'll talk about a few of them, but there's a lot of open source projects in the motion picture industry that have been created by vendors, by studios. There we have a landscape that you can check if you want to have to explore all the open source projects in the motion picture industry that you can apply to a lot of other industry by going to l.aswf.io. You have that list, and if you click on those cards, you can go in and dive into the community and people who are doing it. Now, our foundation was created through an investigation of the Science and Technology Council of the Academy of Motion Picture Art and Science. That is a part of the Academy. So the Academy of Motion Picture is very well known for the Oscars and all the great activity that is around the creative folks. But their name is the Academy of Motion Picture Science and Art and Science. And so on the science side, they have a group called the Science and Technology Council that does a lot of activities. One of them in 2016, more than 8 years ago, now we had an investigation the SciTech Council made around open source software. So at that time, there was a lot of open source software being used in the industry, but there was no structure to support them. And as often happens, I'm sure you've heard the stories, from time to time, an important open source project that was used by many studios would lose their maintainer. And then there would be a moment, what do we do? And this would happen right and left. There was a growing use of open source software in the motion picture industry. And at that time, this investigation was put together to analyze the problems with open source, of which there was a few that had been identified. But over a period of 2 years, that roundtable evolved into a place where the discussion would be about the value of open source, which was recognized as being very important, and how the community needed to support the open source effort. So to make the story short, we invited the Linux Foundation to that discussion, and Jim came along with Mike Dolan and presented what the Linux Foundation does and how they could help us. And in the end, it was agreed upon that the Academy and the Linux Foundation would partner into creating the Academy Software Foundation to provide a neutral forum for open source software developer in our industry. This is about our industry and helping and grow open source software in motion picture, but we really also want to make our projects available to other industry, and that's why we're talking to you here, as we think that a lot of computer graphics historically has come out of the motion picture industry for high quality photorealistic rendering. The motion picture industry were the first to do this, and all was very open at the time by this conference called SIGGRAPH, where many of the studios presented their algorithm for rendering, and this was a very open process from the beginning, and then open source software grew out of that. And we want to continue offering our technologies to the rest of the world. So our mission statement is to increase quality and quantity of open source contribution, by establishing a governance model, legal framework, and community infrastructure, all things that were missing from our open source community of multiple projects that were led by very passionate developers, but that had various levels of support depending on which company they were part of. So we have a document, report on open source and entertainment that documented the why and the opinions of the people who created the foundation now 7 years ago. And you're welcome to go see this report at report.aswf.io. You have interviews from people from Sony, from Pixar, from ILM who gave their opinion on open source and why the foundation was created. So open source is a better path to technology development. Yeah, it's a statement that is not unfamiliar to people in this room. Also, we believe that open source is the best path to collaborative development. And in our motion picture industry, that has become truly the case. After our foundation has been here for 6 years, we are really seeing there was a pent-up need for collaborating between studio, between vendors on important software in the infrastructure of making visual effects and animation movie. And that has proved to be true more than ever as we develop over time. So what we do at the foundation, we do the project infrastructure to help the project, both the built infrastructure as well as everything that has to do with coordinating meetings, having shared calendars, having reminders, and having a place to save the minutes and save the recordings of the meetings. And we hold 350 meetings, more or less, a year between our 15 projects. And all of them are recorded. And if you decide to jump in and come work or are interested in one of our projects, all of those are published. You can catch up on a project really fast by looking at the history. We do the marketing, the events. The legal assistance will be provided by the Linux Foundation whenever there is an IP question that comes up. We do the funding, standards facilitation to a degree, training and education, and open source evangelism like we do now. This slide, it's kind of a visual overload, but it's the timeline of our foundation up to now, starting with the companies that were there at the beginning, at the funding in white over there. The project that joined us in Ochre, the first one was OpenVDB in 2018, and then a number of other OpenEXR, OpenQ came over time to the 15 projects we have now. The companies that joined the foundation over time, the events that we do, the heartbeat there is our open source forum and our open source days. Our membership is made of a blend of the studios that make the movies in Hollywood and the vendors that are helping the studios. Both this whole ecosystem is reliant on a number of open source projects that they have adopted open source project over time more and more. But this is more than companies. The people that are coming up and our board representative from each one of these companies are the one who move things forward. So we're very grateful to our board. We have 19 people on our board. It's a big board and a good board that is involved into our foundation and moving things forward. Each governing board has an alternate that can replace them when they cannot be attending the board meetings. And the mind and the heart of the foundation is the TAC, the Technical Advisory Council, that Larry is leading, along with co-chair Carol Payne, vice chair. And these are the engineers, the head of each one of the projects, along with other representatives from the board companies that are there to really steer the foundation, the technology development of the projects, steer and coordinate them moving forward. And I'll say a few words about our events. We have 2 events a year that are open. One of them is the Open Source Forum that takes place in February, where it's more of a team-based event where we take on a particular topic. The one that we just had in February was held at Walt Disney Animation Studio in Burbank, where we tackled the topic of new technology impacting studios, which was another way to say AI and machine learning. And the whole discussion was around that at the time. And a lot is coming out of it that we will announce at our next event, which is coming up on August 10th in Vancouver, Canada, as part of SIGGRAPH. So Vancouver, if you are going to be there, please sign up for Open Source Days. The sign-up page is open now along with the schedule. Go to opensourcedays.aswf.io and sign up for the events. If you cannot come to Vancouver, they will be online on Zoom, and you can attend them remotely. So I invite you to do that. And we have on our YouTube channel, the Academy Software Foundation YouTube, the recording of our past events. So you want to catch up on some of our projects, you can go and see them there and learn about what happened. We're going to have up in the leading to Open Source Days on August 10th, we're going to have virtual town halls that will happen online prior to the show, where every project or most of the projects will give an update on where they're at in their the kind of the baseline topic, so that at SIGGRAPH and at Open Source Days we can discuss the incremental projects. And finally, before I pass the microphone to Larry, I want to show this slide, which represents our foundation graphically, with the TAC being at the center of it, with all the engineers from all of the projects reporting to the TAC. And each project has a TSC that is very active and every 2 weeks meeting to manage what the development of each one of the projects based on our continuous integration platform. And the TAC is leading the way for the development of open source in the motion picture industry. The governing board is there to help on everything that has to do with money and legal and whatever is needed for the TAC to move forward, removing the roadblocks. And our outreach committee is there to publicize and put the events, put things together. So without further ado, I'd like to introduce Larry Gritz, head of the TAC.
See if I can make this work. Yeah, hi, I'm, oh boy, do we not have speaker notes? Oh yeah, we do, we're good, it's all good, it's all good, yeah. Hi, I'm Larry Gritz, I'm the TAC chair, and my day job is as a software architect and distinguished engineer at Sony Pictures Imageworks. So I'd like to give you a tour through some of our projects. I think each one of those, rightly deserves an hour-long talk, but they didn't give me 15 hours. I'm told I have 15 minutes, so I'm gonna take a few shortcuts. And what I wanna do is take 4 of them to particularly highlight that I think you'll find have sort of interesting, insight into the deep problems that we tried to address with open source in the film industry. And I'll also take a speed run through a few more, but I can't get to them all. So OpenEXR is our oldest project, dating from internal development at Industrial Light and Magic in the late 90s and open sourced in 2006. It was the first visual effects studio originating open source project. And this is the one that really got the ball rolling in open source for the whole industry. For us, it was a bold move, and it set the direction for other studios to follow suit. It's really the important file format that's used for high-quality imaging workflow in visual effects and animation. So what's the problem that this project is trying to solve? So you're probably all familiar with common image formats that you might see on the web or saved by your cameras, such as JPEG or PNG, and mostly those store 8-bit integer values, meaning that they can represent 256 different gradations of brightness in each of red, green, and blue. But the world doesn't have only 256 levels of light or any real maximum at all. And so this might lead to very little, the fact that these encoding limitations that we put on it might lead to like loss of detail in the dark regions or really blown out in the bright regions. For example, in this image, the sky is sort of completely blown out at 255, and so something's lost there, right? If you scale the image intensity down, all you get is still an equally flat sky, but now it's a middle gray. So that's not very helpful. The problem is we can't get back to the original detail of the scene that we wanted to capture. So even if we move to like 10, 12, or even 16 bits, We'd have much finer levels of gradation of color, which is nice, but we would still have that same hard brightness limit. So in film, what we really want is real-world style images with lots of extra precision and range to fully represent what we could capture, compute, or display. So we prefer floating point representation for the pixel values. So with, how does this work? With extended range, we see that the sky is orders of magnitude brighter than the hollow of the tree and brighter even than we can display. By storing all of the full precision and range, if all the data is still there, we can scale down the intensity of the image and see that the original detail and coloring is still there. And that's what OpenEXR gives us as an image file format. And there are other unique things about this format too. And just as one example, OpenEXR images are not just limited to red, green, and blue, but they can store any number of channels with arbitrary names. And so just as an example, for the kind of high-end renderers we use in film, their output isn't just a single RGB image, but often dozens of channels that include all sorts of additional per pixel data that are used for later stages of the processing. And OpenEXR is used everywhere. It's probably fair to say that every movie that you see, and not just the big sci-fi superhero films, but almost all films, very likely had every one of its frames stored as an OpenEXR file at some point in its production. OpenVDB is another project that's been around for a while and is ubiquitous in film. It started out at DreamWorks Animation and was open sourced in 2012. And it's embedded in all sorts of the big major software applications that we use. And it was the first project that was accepted into the ASWF immediately after the foundation was formed. So what's this project about? It's a C++ library and file format for storing and manipulating large-scale sparse volumetric data. All right, what's that? Is this gonna play? Great. So all through animation and visual effects, you'll see the result of physical simulations that we do. So for fluids like smoke, fire, explosions, flowing water, clouds and mist, that sort of thing, the underlying representation is volumetric. So think of it like pixels of an image, but it's in 3D. So the size of the volumetric data grows with the cube of the grid resolution, but often the interesting parts, like where the fire or water actually is on a given frame of the animation, is only a small subset of the possible domain. So what we want is a way to store and manipulate the data so that it only takes up memory where the fluids actually are and can have a higher resolution representation where there are interesting high-frequency details happening, and lower resolution where things are changing slowly. So OpenVDB then is a spatial data structure that gives all of those advantages, a library for manipulating these sparse volumes in lots of helpful ways, and a file format for storing them efficiently on disk. Additionally, there's a variant called NanoVDB that's an alternate way to store the data structure that's especially friendly for GPUs, and also Neural VDB, which is a neural net representation of a highly compressed version of the data. All right, next up is OpenColor.io. This was originally developed at Sony Imageworks in the early 2000s, open sourced independently in 2010, and put into the foundation in 2019, while simultaneously getting a major rewrite led by Autodesk. So it's a really good example of some of this like very deep collaboration between different companies. Today it's used across the industry and is embedded in many products. And it's the backbone of color workflow in visual effects and animation. But what is color workflow? So let's go back to our OpenEXR image. So we talked about how we're storing per pixel high resolution, high precision and range values. But what do those numbers actually mean? So there's two broad categories of color data. What we call display referred is sort of the fundamentally 0 to 1 range that's related to the minimum and maximum brightness that a display can show or that an image sensor can capture. And what we instead we call racine referred is a measure of light intensity like you get sense in the real world. It's not relative to any particular display or sensor, and because it's, light has no maximum value, so there's no maximum brightness to it. But we understand that a number like 100 is pure red, but which red is it, right? Is it the red of the traffic light, or the red of the laser pointer, or is it the red in the pan of paint you got from the hardware store, right? So we have to figure all that out. And we want the ability to take the set of colors in an image and make sure that they appear the same on any display. So how can we be confident that the viewers in the theater are actually going to see the same colors that was on the desktop display of the artist that composed the image and had it approved by the director, right? We want to know what people are really going to see, even if it's on a very different kind of device. Those RGB triples are the weights of the color primaries. So think of that like the 3 different colored phosphors that used to be on CRTs. So these primaries are the points in some space of all colors that humans can perceive. And a display can show any color that's within the triangle defined by its 3 color primaries. But different types of displays have different triangles. But if we know how they relate to each other, we can figure out how the same color on one display can show up on a different display. It's a change of coordinate systems. So what OpenColor.io does is let you define these color spaces and the math that you need to transform from one to another as a library and a file format that stores the configurations for these. Color workflows are super subtle. I'm not a color scientist, but they're tricky enough to get right that every major studio has a dedicated color scientist on staff, making sure that we're not messing this up as we are passing through the pipeline. It's really tricky, and OpenColor.io is one of their most important tools. So Open Shading Language is another widely used project that originated at Sony Pictures Imageworks. We open sourced it in 2010 and turned it over to the foundation in 2020. It's the most widely used shading language for high-end path tracing renderers that are used in film production. And it's used in many products as well as proprietary renderers in different studios. You may be familiar with shading languages used for real-time computer graphics. OSL is similar in flavor, but it differs in a number of ways that are specific to the needs of the high-end, mostly not real-time path tracers that are widely used for final frame rendering for films. Underneath, it uses LLVM for JIT code generation, targeting Intel and ARM for shading single points at a time, and Intel AVX SIMD-based batch shading of multiple points at a time, as well as compilation to PTX for execution on GPUs using NVIDIA's CUDA and OptiX ray tracing toolkit. So I didn't pick those for projects to go into more detail completely at random. Actually, they have each been so widely influential to how modern digital films are made that each of their original author teams have been recognized for that work by winning Academy Science and Technology Awards. In fact, OpenVDB even won twice, first in 2014 and then again in 2024 because the continued advances of the project over the years resulted in the Academy realizing that they underestimated its importance the first time around and wanted to recognize some of the additional contributors that had come along in years since, as well as upgrading the original authors to a higher level of award. All right, so in less detail, I'm going to speed run through a few more of the projects just to give you a flavor of the breadth of what we're dealing with. So yeah, OpenTimeline.io is a lingua franca for interchanging editorial timeline information between applications. So these are things like the timing and transitions of video clips, how the tracks are combined, metadata, and so on. It was originally developed at Pixar Animation Studios and became a foundation project in 2019. Material X comes originally from Lucasfilm and Industrial Light and Magic, and it is a means for interchange to exchange that the materials and patterns descriptions can look the same even when moved between applications and different types of rendering pipelines entirely. OpenQ is a production quality network queue management software. So this is the piece that orchestrates doing the rendering and compute jobs, spread across sometimes tens of thousands of cores in render farm or on the cloud. And it started out as the in-house render queue manager at Sony Imageworks, but in collaboration with Google Cloud, was turned into an open source project in 2019 and put into the ASWF. We found that it's very hard for researchers and students and even software companies to be able to test technologies that are made for the film industry if they don't have access to the output of a real working film production pipeline and crew. And to generate the kinds of insane data that come out of the crucible of production. So the Digital Production Example Library, or DPEL, tries to address this. And it's not software, but it's a collection of production complexity assets and scenes, warts and all, that people can use in sort of limited licensable ways for testing other projects in software. OpenImage.io is an API and library for reading and writing many different image file formats and doing all sorts of image processing and handling tasks that are typically done in renderers and film production pipelines. And it's another one of those projects that probably touches every single frame of almost every film with any visual effects in it, all behind the scenes. The Open Review Initiative hosts two related projects. Is that gonna? There might be some video, yeah. OpenRV, which was contributed by Autodesk, and XStudio, which was contributed by DNEG. Both of them are production-grade media and review tools. The way tools like this differ from like the kind of media playback system you would use to watch your cat videos, is all about the advanced collaboration features, such as managing shot lists of shots to be reviewed, orchestrating synced viewing between multiple people, potentially at multiple sites, and the ability to do things like annotate images with drawings or notes, because these will all get turned into the marching orders for the artists to go and improve those shots that are being reviewed. Did that. How do I? Yeah. And so the last project I'll mention today is one of our newest OpenAPV, which was contributed by Samsung as a sandbox project. It's a new video codec that is competitive in quality with some of the leading professional formats, but it was carefully engineered with the specific purpose of using only algorithms that are completely free of any patent or licensing encumbrances. And so that's my quickie whirlwind tour of the projects. I know it was brief. I didn't get to all of them. I apologize to project leaders out there. I had to cut somewhere. But if there's room at the end, we can answer more questions too. Right. And back to David.
Thank you, David. All right, so you can scan this and it'll get you to our project page and you can get in more details about all of them. We invite you to do so. We're already close to the end, so I want to also talk about the working groups that we have at the foundation. So sometimes before there's a project, there's a working group. That was the case with DPEL and some of the projects that Larry presented. Currently, we have 4 working groups in operation, with one more coming up soon that we'll announce at SIGGRAPH. The CI Continuous Integration Working Group that was very instrumental in developing our build infrastructure that we have, not only for the Linux side, which most of the studios in our industry use, but also developing a build infrastructure for the Windows side, which the smaller visual effects companies and studios will often use as well. And they're very active and very important. We have a great diversity and inclusion working group that was started not long after we started our foundation, when someone pointed out that around the table that I showed, it was all white males, right? So we did something about that, and our DI, Diversity and Inclusion Working Group, helped us by presenting options of what we could do and what we could change the guidance to increase diversity in our foundation, and they're incredibly active. I'll talk about something else that the D&I group has done. We also have a USD working group, a place where the people using the Universal Scene Description Project, which is a project held at Pixar and also developed toward the specification at AOUSD, where we have Guy Martin here, the chair of AOUSD, with us. Our Universal Scene Description Working Group is a place to discuss the film application of USD. And we have a new Zero Trust Working Group working to support our projects that need to function in Zero Trust security environment, very important security. And so we do a number of events, and this one, the Summer Learning Program, is an initiative that was started by our Diversity and Inclusion Working Group, reaching out to underrepresented communities, to schools, high schools, going to present and talk about how you can be an engineer in the motion picture industry, to young people who are looking at what to do in their career moving forward. They've done an incredible job with the Summer Learning Program, a small program with about 20 people coming in, young people, and you can see a list of where the graduates of the Summer Learning Program have gone after that. We also have an important conference or hackathon called Dev Days that we now have twice a year, a place where you can come in and do your first contribution to any of our projects. These are the days where we have our projects all hand on decks, ready to help the community and to people that are coming for the first time, where you list of issues that you can pick from. We had one in May. The next one is going to be in September 15. Check it out on our website. And a few statistics. We're a community of about 5,000 people on our Slack workspace. We have about 1,000 monthly active users, so we're not big compared to the Linux and many of the other projects, but we're mighty, we like to think, and we work on this incredible place where we help people create images using computers. So we host all these meetings and support our community that is growing rapidly. So if you want to join us, if you want to contribute, here's some general instruction on how to do that. You can get involved. You can join the meetings. Everything we do is open in the true open source fashion. And you can join our mailing list. And if you want, as a company, want to join, which is the way we fund our activity, is through our company members. You can pass this to your manager to go at ASWF.io join. But all our activities are open to individual engineers and people. And please come and check us out. How to participate? This is the code that will get you to our Slack space if you want to participate. And that's it for us. Thank you. And we have a few minutes for question and answer if you have any. Yeah. Any questions for Larry? He's the one with the real things to be asked to. Yes. Yes. You want to take that one? Come on up. I'll turn myself off.
Yeah, it's a little bit different area. Some of the things are more applicable than others, but yeah, a fair amount actually is. And there's been a lot of cross-pollination over the years between people who actually have gone back and forth between game companies and film companies. In fact, just to pick one example, the open shading language, which I'm the architect for, the chair of the technical steering committee of that, used to work with me at Imageworks, but now he is at Epic Games, but he's still the chair of the TSC for that project. And we have a lot of cross-pollinating participation like that.
Epic Games is a member of the foundation, and they have, since they started doing a big push in film about 5-6 years ago, they've adopted a number of the project in Unreal Engine and supporting them in their aim to have the engine used in film applications. And as you probably know, they have produced a lot of linear content, the Mandalorian, the whole virtual production, interactive graphics on video walls. driven by Unreal Engine, and now there's a number of other tools that do that. But Epic has been aggressively investing in the film industry and adopting many of our projects.
Another one of the ways that there's a lot of crosstalk these days is the film production uses the game engines in particular ways in certain parts of the pipeline more and more. So that creates a lot of pressure for things like the color workflows and the higher quality imaging and things like that we expect in the film to need to get pushed to the game engines as well to make them fit into those pipelines. So it's a dialogue.
Yes, in the back.
Yeah, so HDR monitors are like one of the kinds of displays that we have to cater to. I mean, in general, the sort of the computation pipeline tries to carry everything through in pretty close to full precision, and anything that has to get sort of truncated or adapted to a particular display is something that happens at the end. But like part of the point of like a really strong color management workflow is to actually understand what transformations are happening at every step, so we can preserve that and know at the end of the pipeline how is it going to display in a theater, how is it going to display on an HDR monitor, and so on. So yeah. So there, sorry, just to make sure, she was asking, is there a display, testing room? Yeah, so all of the studios where we're authoring these things, have like specially calibrated, not just the displays, but like understanding the luminance conditions of the room you're viewing in and everything. And so we don't have to test it all the time, in the sense that like the knowledge of everything that we've measured from the different kinds of displays and like really understand what their properties are is kind of baked into what OpenColor.io understands about the different color spaces. And I've oversimplified, right? Like there's this sort of the abstract, color spaces it's dealing with, but it's also handling things like the transformations of like how to make it look like it will appear on a particular display so we can preview it, and like what are the color properties of the cameras when they get ingested at the front end of the pipeline. It's like the whole thing, yeah. And there's another project, not currently part of the Software Foundation, but from the Academy of Motion Picture Arts and Sciences Technology Council, called ACES, the Academy Color Encoding System. So that's a sort of film industry-wide standard for transmission and archival of the color. Like what do the pixel values mean when you archive a film? And even to the point where like 50 years later, there's some new display technology, like what's it supposed to show that matches what the filmmakers think that they made at the time? So like there are people who work on this very hard at levels that I don't begin to understand. But yeah, it's like the color management is a big deal.
Another question about something that struck me. It looks like all your projects were company-given, right? Do you also see small projects like grassroots projects?
Yes.
Like individuals? I mean, I would understand, but it's
Yes.
something unique.
Right. So the foundation and the projects in the industry are going through, like a growing maturity. So I would say like there's kind of 3 stages to the projects that we've taken on. The first stage were like the projects that were in a little bit of trouble and needed the foundation to prop them up because maybe they'd lost maintainers or people weren't, there was a risk management issue to be solved there. And then the next phase was projects that had been open sourced by one company that maybe everyone was relying on, but by turning them over to the foundation, made them much more of a community developed, and neutral from there on out. And now we're in the third phase, where we're starting to see projects that didn't exist before, but several companies will come together and say, hey, let's work on this thing in the foundation from the ground up, because we know we want it to be a shared resource. Let's just do it that way from the beginning. So like that's the phase that we're in now. Yeah.
So similar to display technology, do you know if any camera manufacturers are adopting like OpenXR for HDR?
I don't know. Do any of my Sony colleagues know? I don't know. I mean, mostly, yeah, like, mostly the camera raw formats are still, integer based, so there's some, maximum brightness. I mean, the sensors obviously have a maximum, but like, I don't know if there are any currently that, I'm not honestly sure.
Yeah.
And most of the film, the digital motion picture cameras, like, you shoot the movies with, they each have their own formats too, and they often store, HDR data there. But usually what happens is by the time it gets to like effects and animation, those things are all ingested and turned into OpenEXR and go into the OpenColor.io, color workflow, and like we treat them all as, digital, EXR files, sort of all the way until the end,
Right.
when it has to, go out to another format that's going to be the thing that they actually ship to the digital projectors in the theaters.
Computers started to get used in the motion picture business at the time where there was no real-time rendering. Everything took a long time to do. So, and it's the visual effects and animation industry that took the lead in developing computer graphics in motion pictures since many years ago, 30 years ago plus. We don't have a lot of camera vendors at this time in the foundation, but we're intending to expand from the visual effects and animation place where we came from, where most of the code has been written, into other areas such as cameras and software and computer graphics is in every part of movie making now. So we're starting and we're growing into these areas to have camera vendors joining us as well. Stay tuned for announcement. Come to SIGGRAPH. Maybe you'll hear some announcements that are related to camera vendors.
The question was about, do we have projects with, sorry, what was the phrase you used? Distributed computing?
Distributed computing or compute challenges.
Yeah. I mean, there's this, so for distributed computing, I would say maybe one of the most relevant projects is OpenQ, because that is fundamentally about cloud infrastructure and on-premise infrastructure across many machines and how the jobs are orchestrated. So I think that's kind of in their wheelhouse. I think almost all the projects have like some sort of like serious compute challenges in the sense of like they're all doing very compute intensive things for the most part. And so there's a lot of kind of low level, like how do we optimize this and attention to the algorithms and stuff throughout. I think that across the projects, there is a bit of a trend to like, we're very heavy on things that are sort of core foundational technology, file formats and libraries and kind of computations that happen under the covers. But those are used as the foundation for a lot of higher level, both proprietary like in-house products as well as the big commercial products like we mentioned Blender, but all the commercial ones are like that too. Underneath, like every one of the big, commercial, animation systems are using most of these projects because like they too realize that there is no point reinventing the wheel and then being incompatible with what everyone else is using. So we're all using a very large, shared core infrastructure these days. And it helps a lot because no one has the resource to invent all of these things alone. We have to share the development costs and the risks.
All right. Do we have one last question? Yes?
So what about distributed content management? So the review tool looked like it might have some elements of distributed content management.
By what I think that you mean by distributed content management, I don't think we have anything that directly addresses that now, but Yeah, I mean, we're 7 years old and still taking things in. And, we're very heavily in animation and visual effects, but the vision of it is to be film industry wide. So we're very open to branching out into other areas, but projects kind of have to come to us in order to do that. But we're trying to put out the word of, our little corner of the industry, I think, was ahead, both for certain technologies, but also for the use of open source. But hopefully this will pave the way for other parts of the film industry, including some of the distribution issues.
We have not spoken about all the open source software that's used in the motion picture industry, that every industry uses for infrastructure and distributed content management and database management and all the rest of it, including Linux, which is omnipresent. So these are things that are present, but they're developed, they're well taken care of by other organizations. We're focusing, as Larry said, on the image generation side of the equation. And we want to thank you for coming to see us today. I hope that you found something new, and you are welcome at the Academy Software Foundation anytime. Please join us. Thank you. Thank you, Larry.